Hello everyone, welcome to my YouTube channel, and today we are going to solve this integral over here, that is sin t cube x into d of x. Now if I use the basic integration technique to solve this integral over here, then simply I will get sin cube plus 1 of x divided by 4. This will simply become sin of 4x into 4, and this is not the way to solve this integral because this is a trigonometric integral and we have to use trigonometric identities to solve this integral over here. What I can do is I can divide, or I can split this sin cube x into two components. One component should be over here, the next component should be over here into d of x. Now I can say that the next component should be sin of x and the first component should be in the form of cos of x. Component should be in the form of cos of x, as if I take the derivative of this cos of x, then I will get simply minus sin of x. That's over here. So I need to convert this or split this into two components. One of the components should be sin of x and the other component should be simply cos of x. Now if you have an integral, for example if I take integral cos cube of x, then you need to split this cos cube of x into two components. First component, second component, and the second component should be cos of x and the first component should be in the form of sin of x, because if you take the derivative of sin of x you will simply get cos of x. So keep this thing in your mind if you have to integrate sin of x or cos of x respectively. So I have a very nice identity, that is simply sin square x plus cos square x equal to 1. So if I am writing this sin cube x as sin square x into sin of x, then I can say that I can just use this trigonometric identity to find the value for sin square x. Sin square x is simply equal to 1 minus cos square x. So just you need to plug in the value of this sin square x over here in this integral. So if I plug in the value of this over here, then simply I will get 1 minus cos square x into sin of x into d of x. So now, as I said earlier, that you have to plug in the component of cos of x here, as if you take the derivative of this cos of x, or if you substitute u is equal to cos of x as you are taking the derivative of cos of x, then you will simply get sin of x. So I say that u is equal to cos of x, as we are using the substitution method. First we have used the trigonometric identity, now we are using the substitution method to solve this integral. U is equal to cos of x. Now I need to take the derivative of this cos of x, then simply it will become du is equal to minus sin of x into d of x. Now from here I can find my d of x. So d of x, by rearranging this equation, d of x is simply equal to du divided by sin of x, and you have to add a minus sign over here. So just plug in the values of this u is equal to cos of x and d of x in this integral over here. So if I substitute the values, simply I will get 1 minus u square into sin of x and to 1 divided by sin of x and add a minus sign over here into du. You can see that this sin of x will cancel out with this sin of x, and I will simply get, and just plug in the minus sign over here in front of the integral sign, you will simply get 1 minus u square into d of u. Just this is really simple, you just need to integrate u square and 1 over du. So I will get minus into u minus u cube divided by 3, and this is simply plus c. Plus c is simply the constant that we used to add if this is an open interval. As you can see, this is an open interval, as I have no upper bound and lower bound, so I need to add plus c as a constant. So simply minus u plus u cube divided by 3 plus c. As you know that we just mentioned that u is equal to cos of x, so you just need to plug in the value u is equal to cos of x in this u plus u cube over 3. So if I plug in the value u is equal to cos of x, then I will get cos of x minus cos of x plus cos of x divided by 3 plus c. This is really simple, and in this way you can get the integral or solve the integral easily. Now remember one thing, that you don't need to use, if you have an integral this sin cube x into d of x, you don't need to use the basic integration technique, that is simply sin cube plus 1x divided by 4. This is not the way to solve this integral over here. The method we have discussed, and this is the way to solve this integral.